136. Okay, today I'm gonna be talking to you about heliopause, just a little scientific lesson, just a food for thought, you know. But do y'all remember when y'all first was in kindergarten and your teacher asked you to pick a planet that you want to study? And do y'all remember that feeling of how y'all felt when y'all had to study this planet and like now y'all want to know what's out of space? So figured I'd do about heliopause. Little facts about the sun. Heliopause. What is heliopause? Heliopause really has no definite definition, but the theory of heliopause is that at the end of our solar system, which is called the Milky Way galaxy, basically there are solar wind that travels down through the galaxy, and at the end of it, it's almost as if it hits three stages. It hits the slow down phase, then it hits the stagnation phase, then it hits the depletion stage, and that's where the theory of heliopause actually comes from, where everything comes to almost a complete stop. But this zone actually is fixed in AUs because you can't really use actual miles and kilometers and all the stuff in space is different. It's called AUs, and it's about 10 AUs, which equals up to about maybe 11 billion miles. So that's just something to think about. But to actually understand heliopause, you gotta understand where solar wind derives from, and it actually derives from the sun, but more or less it derives from the sun's corona, which is another layer of the sun. The sun has multiple layers, but basically what it is heat travels from a high plane to a low plane, and it causes a dispersion of like the wind traveling on the sun. So basically like the radiation from the sun, and it makes charged particles as almost like they're radioactive. That's why we have ozone layers and all our, basically our whole atmosphere, because if we didn't have it, it couldn't protect us and it just cause havoc. But basically this wind travels at such a speed, it travels faster than the speed of sound. It almost travels the speed of light, but it's not really light, it's wind in space. But it travels all the way to the end of the galaxy, and a thought about that is at the end of heliopause, the wind actually stops because it no longer is in our galaxy. It goes into the universe, but at the same time, if you think about it, if this was the universe, this solar wind is actually pushing our whole galaxy slowly but surely, and maybe one day it's theorized that maybe one day that we maybe even crash into a different galaxy, but I don't think we'll be allowed to see that. This is just a picture, like just to give you a basic understanding of it. This right here, all this right here is solar wind, and this right here is the Milky Way galaxy. This is the end of it. So I guess you could say that's kind of near Pluto, maybe a little bit further. But basically the understanding like of this is like the solar wind goes this out, and this line right here is actually the heliopause, and what's in between this is the universe, and what this is the interstellar medium. And basically the interstellar medium is a scientific term for space debris. So it could be anything from gas particles to stardust to maybe even like it could be anything, but no probe has been out there thus far, so there's no really telling for sure what it could be. The actual origin of heliopause, helio means sun and pause means like the stoppage or something. It's basically just what I was saying prior to this, how it travels to a certain thing, but the actual speed of it is 440 kilometers per second, so it travels pretty fast. Here you go. If you didn't understand the last one, this is more of actual diagram of like what it is. Like I said, heliopause is actually like stop of the solar wind into our galaxy, and just pretty straightforward. Pick a video, kind of explain it.
Diving through loop 1 towards our solar system, we must change our viewing scale by orders of magnitude. Here, we find a new structure, the heliopause, created by the interaction of the outflowing solar wind and the motion of the sun itself through the local interstellar breeze.
Something. But as you can see, like I was saying prior, that our galaxy is not stagnant. It actually moves. So everything is moving because everything is still expanding due to the Big Bang. So, and here go another video of it zooming out, showing you. Well, that was the end anyway.
Okay, yeah, go ahead. No? Okay.
I mean, I can end it now.
No, you keep going. That's all right.
Well, basically, long story short, how we know the information is the Voyager 1 is actually a probe that was launched in 1977, and it didn't get to this spot until last year. Well, not last year, but 2 years ago, 2012 in August, and it fed us this information. So, it's the Voyager, and thank you for your attention.